Hello students, here we will deal with the problems. Before going for the problems, we just glance on the topics like how to write, what are the types of supports, what is its representation and what are the reactions. So simple support, it is represented like this in simple manner, and the reaction is one reaction vertically upwards. Roller is, this will be the two representation, circle and triangle with a circle, and again it is also having one reaction, that is a vertically upwards. Hinged pinned is having a representation of this mesh, and where the two reactions will be one vertically upwards and horizontally another reaction will be there. Fixed rate has one representation and three reactions, including one rotation. Horizontal and vertical reactions will be there. And how to convert UDL and UVL into point load? If UDL is given like this, where the beam is given with the length of L, AB, and intensity of UDL is W kilonewton per meter, then it can be converted as a center point, the converted as a point load. The position of point load is at the center of the rectangle, that is center point of L. So it will be L by 2, L by 2 from either the side AB, and the intensity is nothing but area of the rectangle. Rectangle is a base L, height is W kilonewton per meter, which will give W L kilonewton. Next, UVL is represented as a right angle triangle like in the figure, where AB is a beam of length L. So maximum intensity is W kilonewton per meter. So this can be converted as a point load, that is the centroid of the right angle triangle will be towards the 90-degree side. So it will be somewhere towards the point B. So intensity of the point load will be half into base into height, that is area of the right angle triangle. Half into base is L, height is W kilonewton per meter, which will be half WL kilonewton. And the position will be 2 by 3L and 1 by 3L from point A and B respectively. As well as we need to know the condition of coplanar concurrent force system, that is three conditions: sigma h is equal to 0, sigma v is equal to 0, and sigma m is equal to 0. This you have to apply and find out all the unknown reaction that is present in the problem. And before going to the problem, I suggest you to see the class number 11, where I have told you to select about 10 random problems and write on the notes. So if at all whatever the problems I'm going to do here in this video, if it is not present in your class number 11 or you have not written in the notes, you can copy down this note, that problems, and solve on your own by seeing the video. So let us start with the first question, a simple one. If you want to write the question, you can write down. So I'll repeat the question twice. Find the support reaction for the given beam of length 5 meter as shown in the figure. So I repeat the question. Find the support reactions for the given beam of length 5 meter as shown in the figure. And the figure is given like this. A beam of AB is given with the support at A and B like this, and it is added with the load, that is point load 3 kilonewton and 6 kilonewton at this position. So this 3 kilonewton and 6 kilonewton is at a distance as is shown in the figure. So it is from here to here 2 meter, here to here it is 2 meter, once again from here to here it is 1 meter. So this is a given question. Now this figure is present in space diagram. The first thing which we have to do is convert the space diagram into free body diagram. So for that one, you have to consider all the points wherever the support is present, as well as you have to consider or name the point into some variable wherever the load is applied. So you can see that at this point and at this point supports are given. So which is given with the variable a and b already. So already in the question the variable is given to these points where the support is given. So we need to give some variable name to the points where the loads are applied. So you can see that it is a point load at this point, which I will take it as C, point C, and at this point 6 kilonewton, again another point load is acting, so which I'll take it as point D. So I have to give the variable name for all the points where the support is present as well as all the points where the loads are present. Now in this case both are the point load. So this is a very simple problem. First, this is a step, name the variable wherever the load and support is present. Next, project the lines below the variable points. So that is, below A point you project the vertical lines like this. Next, here the beam is given with some thickness. Since I am taking a beam as 2D element, I can represent it as a single element, single line element. So here this point I have taken it as A here, and this point I have taken it as C, this point I have taken it as D, and this is point B. Name the points as it is. Project the vertical lines below that, below the points, and name the points as it is. Next, if check out the types of loads. If the loads are already point load, write as it is with the given arrow mark. It will be always downwards, and here also it is once again point load. Write as it is with the values. If at all it is UDL or UVL, you have to convert it as a point load and write. The next step is write the distance as it is. That is, between A and C it is 2 meter as per the question. Between C and D it is again 2 meter. Between D and B it is 1 meter as per the question. So next, see the type of support that is present at point A and B where the support is given. It is a simple support, so there will be one vertical upward reaction in both the cases. And after writing the reactions, then you have to name it. Now reaction RA since it is present at point A, reaction RB since it is present at point B. So this is a free body diagram. This we call it as free body diagram. So you can see that a beam AB is subjected with all the reactions and loads in terms of magnitude of force and direction. Correct? All are represented in types of force. So then we call it as a free body diagram. So once it is done with the free body diagram, next you have to apply the equilibrium condition. So since you can see that all the forces present in the problem is parallel to each other, so they never meet at a single point. So it is an example for coplanar non-concurrent force system. What are the condition of equilibrium? Sigma h is equal to 0, sigma v is equal to 0, sigma m is equal to 0. So you apply the condition one by one. We will start with sigma h is equal to 0. So applying sigma h is equal to 0. In the figure, is there any horizontal force? There is no horizontal force. So you will get 0 is equal to 0. Next we will go for sigma v is equal to 0. That is, all the forces present here including the reaction RA and RB, it is traveling in vertical direction. You know that the forces traveling downwards are taken as negative. traveling upwards are taken as positive. In the same way, you take all the forces. So this reaction, which is represented as force, is traveling upwards, so it is positive RA. And this load, which is traveling downwards, is taken as negative 3 kilonewton. Negative 3 kilonewton. Next, this one again traveling downwards, negative 6 kilonewton. Next, this reaction traveling upwards, so it is positive RB is equal to 0. Is equal to 0. So if you reduce the equation, you will get RA plus RB is equal to, what is the value? 9 kilonewton, which will be equation number 1. So this is equation number 1. Once you have applied these two equations, you will get either any one of the value, or you will get a form of equation. Next, you have to apply the third condition, sigma m is equal to 0. You have to apply sigma m is equal to 0 either one of the point where the support is present. So in the figure, you can see in the question, at this point and this point, there are supports which I have represented in the form of a support reactions. So at these 2 points only, either it may be A or B, you have to apply the sigma m is equal to 0 condition. Why? I'll tell you. If I apply here, the force whichever passing over to the point A creates nothing but moment equal to 0. So entire equation you will get only the unknown RB. So if at all the equation is having only one unknown, so you can find out that value. Then using this condition you can find out another value. So if at all you take sigma mc is equal to 0, then again you will get an equation. Then you have to solve the equation. So we shall reduce the steps and find out direct answer in the third case. So if you apply at point A and point B, you will get direct any one of the unknown values, and then you can substitute for the second value in this equation. Or else if you apply sigma m is equal to 0 at any other point, again you will get an equation and you have to solve the equation. So that will be complicated sometimes in some cases of problem. So it is better to apply sigma m is equal to 0 at points wherever the supports are present. Now in this case, supports are present at A and B, which is represented as support reaction here. So let me either choose A or B. So first of all, I'll choose A, point A. So I'll apply sigma m A is equal to 0. So I have to apply moment at this point. The reference point is this one. Because of all the four forces present here, you have to see what is the moment created by that force at point A. So this RA is passing through the point A, so there is no perpendicular distance. So RA is having a perpendicular distance is equal to 0. Next, coming for this point, see again, if you apply at A, you start with this point A, so that the forces which is passing over the point is creating nothing but moment equal to 0. Then you move on to point C, then you move on to point D, then for a point B. So there is no confusion in taking the values. So if at all you start with this point and skip on to point B, sometimes there is a chance that you will miss these two points wherever the loads are present. So you go on one by one with all the forces that is present along the line of beam AB. Okay. So I have started with this point. RA reaction or force whichever present here, it doesn't create any moment since perpendicular distance is 0. Next you move on to the next point where 3 kilonewton force is acting and it is acting downwards, which will create a moment in clockwise direction to point E. So it is a clockwise direction. Always the moment in clockwise is taken as positive, anti-clockwise it is taken as negative. So it is positive 3 kilo force into perpendicular distance force is 3 kilonewton, and the perpendicular distance, if this is the line of action of 3 kilonewton, the point of concentration is this one. You have to drop a perpendicular to the line of action of the force. So this distance will be the perpendicular distance. So therefore it is into 2 meter, correct? Next, this force creates 3 kilonewton with the perpendicular distance 2 meter. Next, the force is 6 kilonewton, which is acting at point D. The force is acting downwards. Again, it is creating a clockwise moment to point A. The line of action of 6 kilonewton is like this, for which you have to drop a perpendicular from point A. So if I drop a perpendicular from here to here, the perpendicular distance will be AD. That is nothing but 2 meter plus 2 meter. So the perpendicular distance to point D is nothing but 4 meter. So it is a force 6 kilonewton acting in clockwise manner with the perpendicular distance 4 meter. So again, and since it is a clockwise, so it will be plus 6 kilonewton with the perpendicular distance 4 meter. Next, you move on to the point B. The force is upwards, that is nothing but support reaction, and since it is traveling upwards, it will twist or rotate in this manner. So it will be anti-clockwise to point A. So it is a negative. What is the value? Value you don't know, that is RB, which you have to find out, and it creates a perpendicular distance. So line of action will be along the force like this. The point of consideration is A. Drop a perpendicular from A to B, that is line of action of RB. So it will be a perpendicular distance from here to here, that is 2 plus 2 plus 1, that is 5 meter. So it will be force is RB, which you don't know, into perpendicular distance is 5 meter, and it is acting in anti-clockwise, which is represented as minus. This equation will be equal to 0 if it is present in equilibrium. So this is anyways 0. The term is 0. Next, you calculate all the values. 6 kilonewton meter plus 24 kilonewton meter is equal to RB into 5 meter, correct? So it will be 30 kilonewton meter by 5 meter. So RB is equal to 6 kilonewton. Then applying this 6 kilonewton in equation number 1, RA is equal to 9 kilonewton minus 6 kilonewton, that is equal to 3 kilonewton is the answer for RA and RB, which are the unknowns for the given figure. So this can be checked. The value of RA and RB can be checked by applying the sigma m is equal to 0 for another point. As I have said earlier, sigma m can be applied to any one of the point A or B where the supports are present. So I have applied here for A and I got the values. This values, whichever I got, can be checked once again by applying a check, that is sigma m is equal to 0 at point B. So I'll apply at point B, sigma m B is equal to 0. So this is the check. Now A is not considered. Now the B point is considered for finding the moment. So B point is here. You have to find out all the moment created by all these four forces. So I'll start with B, point B. The force RB is, that is reaction RB is present at B, which is passing over to the point. So there is no moment created by RB, or I can write it as RB into 0. There is no perpendicular distance to the force RB to point B. Next you go for this point, that is T. Here there is a point load 6 kilonewton acting. The line of action will be like this. So you have to find out the perpendicular distance, draw the perpendicular from point B till line of action of 6 kilonewton, which is nothing but equal to 1 meter. So the moment will be 6 kilonewton into 1 meter. Now the arrow mark is downwards, so therefore it is acting in anti-clockwise manner to point B. So it will be minus 6 kilonewton into 1 meter is a moment created by 6 kilonewton force to point B. Next you move on to point C, where downward 3 kilonewton is acting. Line of action will be like this. Point is here, draw to perpendicular. So the perpendicular distance will be B to C, which is nothing but 2 plus 1 meter. So it will create a moment 3 kilonewton into 3 meter, and again since the arrow mark is downwards, so it will be twisting towards point B in anti-clockwise manner. So again it is negative 3 kilonewton into 3 meter. Next you go for the last point A. There is an upward reaction RA which is to be calculated now, which will create clockwise moment towards point B, and point B is here. Draw a perpendicular to the line of action of RA, which is oriented like this. So perpendicular distance will be from B to A, that is 2 plus 2 plus 1, 5 meter. So it will create a clockwise RA into 5 meter plus RA into 5 meter is equal to 0. This is a 0. Next the unknown remaining is RA, which if you calculate you will get it as 3 kilonewton, and by the equation which you got here, that is equation number 1, before finding sigma MA is equal to 0, by using that equation again if you find out RB, that will be equal to 6 kilonewton. So by this you can check that RA and RB whatever you have got in this sigma MA is equal to 0 will be equal to whenever you apply sigma M is equal to 0, or it will be equal at any point wherever you apply sigma M is equal to 0, but we prefer to apply at E and B since you get the answers directly.